All right, moving on, we have the tuning. Okay, again, very important to keep in mind, whichever instrument you have selected is the one you are adjusting. And right now, we are dealing with, for simplicity's sake, just one instrument at a time here, so we can hear the adjustments we make with no other interference from other layers. Take a listen to the decay of the cymbal where this dragon hits. Now we're going to adjust the tuning. Right now there's no tuning happening, or the pitch. This is nice because if something's too high, too low, you can make those adjustments. So if I pitch it up, we are going up a couple octaves there basically. So we have a lot of leverage with how high and how low we can change the tuning. I can go pretty extreme as well. Now, one thing I want you to keep in mind as well, we have two different tuning models, Tune A and Tune B. Tune A will change the pitch and also will change the length of the waveform. So this is your typical tuning, okay? This is what you would expect. As you pitch up a sound, well, naturally that sound will become shorter in length. Listen to the sustain of the cymbal in its default tuning. I'll just go up basically one octave. Decay is much quicker. If I go down, it will be longer. No surprises there, pretty self-explanatory. Tuning B, the Tune B algorithm basically changes the pitch, but it attempts to leave the length, the original length of the waveform the same. So there's kind of some waveform stretching going on. It's trying to keep it the exact same length. So here's the length where it's unaltered. If we go up, listen to the pitch and the sustain. Now keep in mind, it attempts to keep the length the same, which means the more extreme you go, the more artifacts you're going to have. But you can hear that the length of the waveform is the same, even though the pitch is higher. If I go down, same thing. Now if we go extreme, let's just hear what that sounds like. I'll go all the way down. If I go all the way up, some really weird, almost phaser effect. So the higher you go with this Tune B, the more artifacts you'll have. I mean, it sounds all right at an octave. You can hear a little bit of those artifacts there, but anything below that really should be usable in both directions. Probably more times than not, you'll just use Tune A where, it will shorten and lengthen the waveform, but that may be okay. So even at the extreme settings, it still sounds all right. We have this H and N, it's kind of hard to see. This is the quality of the pitch algorithm, okay? So normal is going to be less CPU strain. I mean, so if you get into these heavy samples, this is probably just good to leave it on normal, but when you're actually recording, bouncing this down, you have your finished product, whatever you're working on, and you're gonna render it out, bounce it down, I would select this high option, high quality. Now let's take a listen. I have the high quality enabled now. No pitch adjustment, we're in Tuning A. Let's go down an octave. And down a full. You may not hear much difference at all, but just want to show you that's what that means. Actually go back down. That's high quality. Let's turn it to normal. Yeah, so you're not going to probably hear much difference. Let's go all the way up, because this is where we hear artifacts. All the way up with Tuning B, normal. The weird phasing. High quality. Let's look at the weird phasing. So I just set it up to high quality. When you're done with your track, bounce it down. Otherwise, the default's normal. I think that'll be fine. And more times than not, you're probably going to use this Tuning A algorithm.